Hello students, welcome to Nagesh Karasgi school channel. Myself Priya teacher and I am going to teach you science subject for class 7. Children, we are discussing about physical changes and chemical changes. So in our last session we discussed what is mean by chemical change, and also we saw different examples of chemical changes. Okay, so many examples we discussed in our last session. So now I am going to ask you some questions, then you have to answer it. Okay, so first question, it is, when you are going to add vinegar into baking soda, which substance you get? Okay, very good. So when we are going to add vinegar into baking soda or baking soda into vinegar, then we will get a substance which is called as a CO2, which is a gas, and also other substances are released. So this is called as a chemical change. And one more question is I am going to ask you, that when we are going to add CO2 into lime water, then which substances we get? Okay, very good. So when we will add CO2 in a lime water, then after that this is a reaction. So after this reaction we are going to get the substance which is known as carbonate and water. Okay, so these substances we will get after adding CO2 into lime water. So this is called as, these are examples of chemical changes, or also we can say that these are examples of chemical reaction. Okay, so all these examples we discussed in our previous session, and also I shown you whatever activities are there, how we can do these activity in laboratory, that I shown you, videos I shown you. Okay, so now today we are going to know that our next point of this lesson, of which we discussed partially in our last session. Okay, so what we discussed last session? Rusting of iron. Okay, so rusting of iron we started. So I only told you that what is the definition of rusting of iron, or what is mean by rusting of iron. So this point we are going to discuss today, and we will start our lesson number 6, physical and chemical changes. So I told you what is mean by rusting, then also I am going to repeat here. So rusting is the process in which iron turns into iron oxide. Okay, it happens when iron comes into contact with water and oxygen. The process is a type of corrosion that occurs easily under natural conditions. So I told you what is mean by rusting. When there is a contact in between iron substances and air and water, what happens? A brown colored powder like structure occurs on that iron substance object, and that is called as a rust, and this process is called as a rusting. Okay, so chemical name of rusting. So what is the chemical name of rusting here? So see, here you can see some objects which are showing here how these are rusted, or rusting process happened here. In this picture you can see some nails are there, and some iron object disc like structure are there also. So chemical names for rust include iron oxide. So what is the chemical name of rusting? So name of rusting is iron oxide. So we know that substances which are made from iron, this is the iron substance. Okay, nails are made up of iron substance. So that formula of iron substance, it is a capital F and small e. So in your textbook you can see after this session. So capital Fe is the molecular formula of these iron substances or iron objects. Then when we are going to get this chemical, we are going to see chemical change in this iron nails, then it means rust if it is there, then molecular formula of this rust it is, or that chemical name we can say, it is a iron oxide, because iron is going to come in contact with oxygen and air. So, ferric oxide and hematite also it is given here. Okay. So, the substances is also known by its chemical formula. See, now only I told you that chemical name, or it is also known as chemical formula, or it is also known as a molecular formula. And what is the molecular formula of this rusting, or what is the chemical name of this rusting? Here it is given Fe2O3. Okay. So, why it is Fe2O3? Because while rusting process is going to happen here, or going to be there, then we are going to add iron plus oxygen plus water. So, in reaction form we can see Fe plus oxygen O2 plus H2O, and it gives Fe2O3, which is known as iron oxide. So, which represents the two elements iron and oxygen that compose rust. So, this is all about rusting of iron. So, what is the best way to stop iron from rusting? So, in our day-to-day life, we always use, there are many objects which are made up of this iron, and if suppose we have to keep these objects in sunlight or the water region suppose, then what will happen, that these objects will get rusted very soon. So, we have to stop it, then it will be not useful for us. That is why we have to stop rusting when we are going to use these types of objects. So many farmers are always using this type of objects which are useful in farming. Okay. So, they keep these objects always out of their home or in the farm sometimes. Okay. So, maybe because of rain it will get rusted. So, that is why what we have to do, that it will not get rusted. So, we can say in simple way that how we can stop iron from rusting. So, spray paint on the iron. So, whatever iron objects are there, we have to spray paint on it, so that it will not get rust very soon. Then one more way is there, second one, to put oil on the iron. So, we have to put oil on these iron objects, okay, to secure them from this rusting. Then third one, put some melted wax also, because of that also we can prevent this rusting of iron. Okay. So, how we can stop this rusting? So, by putting oil on that objects, by putting paint or by giving paint to that objects, by putting some melted wax on that, and also some grease is also there. We see that black colored substance which is grease is always we are putting on these doors, okay, at our home. So, that is a grease also we can put on these substances, so that it will not get rust. But what about those objects on which we cannot put oil or grease or paint every day, or it will be in contact with water every day? So, if suppose some iron objects we are going to use daily, and these objects are going to come contact in with water and oxygen. So, what we have to do, because it will get very soon rust. So, what we can do? So, we have to use another method to prevent these objects from rusting. So, how we can how we can stop? Before that, I want to tell you some examples that where these types of objects are used. So, you know there are big ships are used in navy or for transport, okay, by sea. So, whenever there is a transportation through the ocean or through the sea, then we are using, or this transportation is done by big ships. Okay. So these ships are made up of iron and some other metals. Okay. So these ships are going to travel for so many days, for a month, for 2 months, for 2 months, for 3 months. So they are continuously in water. So if they are made up of iron and they are going to continuously travel through water, then maybe these ships are going to suffer from rusting, and it will not good for these ships. Okay. So what we can do with these ships? Okay, how we can stop rusting of these ships? So there is another way which is known as galvanizing. Okay. So that is this is the next or another way of prevention of rusting of iron substances or iron objects. So what is meaning of this galvanizing? We will read. Galvanizing is a sheet of iron or steel and has a protective layer of zinc. So here in this definition it is given, galvanizing is a sheet of iron or steel and has a protective layer of zinc. So whenever there is a big objects of iron or big substances are made up of iron, so we have to dip these substances, or we have to coat these substances by zinc. So not only zinc but also by chromium or zinc we can coat these objects, then we can prevent iron from rusting. So galvanizing is another way of preventing iron from rusting. So here you can see galvanizing of car. So this car is made up of iron also and some other metals. So we don't want this car get rusted because of air and water, so that we are going to dip this car in this zinc solution, okay, or chromium solution, so that it will not get rusted. Okay. So this is the way of prevention of rusting, okay, for iron substances. So this is called as a galvanizing. So I am going to show you a video that by which you can understand how this exactly done in factories or industries.
Hot dip galvanizing is achieved by immersing clean steel products in molten zinc at 830 to 850 degrees Fahrenheit. But before the steel can enter the galvanizing kettle, it must go through a 4-step cleaning process.
So here you can see some tanks are there. Okay. So some rectangular tanks are made up here and which are filled with some solution.
Yes. The steel first enters the caustic tank at 180 degrees Fahrenheit in order to remove paint residue. It's then rinsed in a fresh water tank.
And here you can see hanger, and to which that hanger some iron parts are hanged here with this hanger, and it is this is going to dip in this tank. Okay.
Tank at ambient temperature. Next, it enters the pickling tank of heated sulfuric acid at 140 to 145 degrees Fahrenheit, where all mill scale is removed. The final step before entering the kettle is the flux tank, which is a mixture of zinc chloride and ammonium chloride at 140 to 170 degrees Fahrenheit. Proper fluxing provides oxidation protection before galvanizing. After the steel has been properly cleaned, it is now ready to enter the galvanizing kettle. The kettle contains molten zinc that is heated between 830 and 850 degrees Fahrenheit. When the steel comes in contact with the molten zinc, a diffusion reaction takes place, forming a new metallurgical bonded zinc-iron alloy layer. Before the steel exits the molten zinc, residue must be swept back to ensure that the material can exit through pure zinc.
So you can see here, so they are dipping these iron parts from one tank to the another, and they are making to dip it into that solution, whatever solution is there. So after this video I will tell you which solutions are there or what are the steps are there. Okay, you have to see here only.
Immediately following the kettle, the steel is quenched in a tank of aqueous sodium dichromate at ambient temperature to help bring the temperature down before post-galvanizing cleaning. This process also enables the zinc coating to remain brighter for a longer period of time. During post-galvanizing cleaning, any drips, marks, excess zinc, or surface dirt is removed. A millage test takes place out in the yard on poles to ensure proper coating thickness.
See, this process is done here. Galvanization process is done here with these iron parts. And what this man is going to do here? So this man is going to inspect that how,
as per ASTM 123 specification,
finally it is
before
done.
it can be shipped to the customer.
It is done properly or not. So one more video is there. So it will explain you how, which are the steps are there. So first step, it is caustic cleaning. So when we are going to dip these iron parts in this solution, what first step is there? So caustic cleaning. So because with this caustic solution we are going to clean these parts first. Okay. So first step is that cleaning. Then second one, after dipping in this first tank, we have to dip this part into another one, which is a rinsing. So again we have to rinse it. Okay, we have to clean it properly. Then third step, which is known as pickling. Okay, so we are going to prepare these parts to get coated by this pickling step. Then fourth one, it is again rinsing. So we are going to rinse it. So flux solution is there. So caustic solution is there, flux solution is there, some acetic acids are there used here into pickling for rinse and for this cleaning of this part, okay, or for making them to get coated, okay, for prepare them to get coated by this zinc or chromium solution. Then now this is the last step, we have to dip this part into the zinc solution or in a chromium solution, we can say here. And after that inspection is there, that man was doing that inspection what we saw right now. So after cooling, last step, cooling and quality assurance, that is done. Okay, so this is the last step. So like these big parts of irons like car or ships, these are galvanized in the industries. Let us move our next point. So here is the picture in which it is given that it has high resistance level of corrosion because of the mild weather in the place situated. So where there is a water vapors are present in atmosphere, these places are having more possibility of corrosion. Okay, so there whatever their iron statues are there or some parts are there, objects are there, they will get rusted. So the stability of these iron pillars are because of their weight, 6,000 kilograms. So and it is originally erected. So it has high resistance level of corrosion because of the mild weather in the place situated. So this is having a more possibilities of corrosion. So rust proof iron pillars. So these are rust proof iron pillars. Okay, so from so many years these are, and these heavy 6,000 kilogram weight they are having. So the first pillar is located in the Delhi near Qutub Minar and was made up by the Gupta Empire kings Chandragupta II. The second one pillar is located in the, so how old it is, no? You read and learn history also, so you know that how old these are. Okay, from so many years these are there in Delhi. So the second pillar is located in Kodancheri in Karnataka and was made by the tribals to welcome the Sant Adi Shankaracharya. Okay, so this is second one. So these two pillars are made up of the iron and these are from thousands of years, they are located here, situated here in sunlight, air. Okay, and these areas are having very we can say cold region, or that possibilities of water vapors or mild regions we can say, then they are having possibility to get rusted. Then also these are situated or located here from thousands of years, because of that they are having rust proof iron pillars, because they are rust proof iron pillars. This means these are iron pillars are also gone through this process which is known as galvanization. Okay, that is why they are remain here from so many years. Then last next is other metals are that can rust. So some steel, copper, bronze, these metals can be get rusted. Okay, so these are other metals which can get rusted. Last point, crystallization. Crystallization is a separation technique that is used to separate a solid that has dissolved in a liquid. So what is mean by crystallization? So we can separate a solid substance which is dissolved already in water or in another liquid. So from this liquid or from this solution we can again get that solid substance, or we can separate this liquid and solid again after making solution also. So the solution is warmed in an, how we can do it? So the solution is warmed in an open container, allowing the solvent to evaporate, leaving a saturated solution. As the saturated solution is allowed to cool, the solid will be separate out of the solution and crystals will start grow. The crystals can be collected and allowed to draw. So what we have to do? So that solution we have to take what in which we added some solid substance in a liquid. That solution we have to take in a container, we have to make it evaporate and we have to leave it for saturation. Then as the saturated solution is allowed to cool, we have to make it cool and then we can get the solid substance is separated from that liquid. So this is called as, this substance is called as crystals. Okay, so crystal is a pure substance we can say here. So importance of crystallization. Crystallization from solution is important industrially because of variety of materials that are marketed in the crystalline form. So this is the first important or first use of this crystallization process. Then second one, crystallization affords a practical method of obtaining pure chemical substances. So this is a practical method from which we can get or obtain pure chemical. Then second, next one, a crystal formed from an impure solution is itself pure. So though it is an impure solution, we get that crystal, then also it is pure substance or in a pure form we can say. Then third one, a drug may remain in different crystalline forms. Some are stable and rest are metastable. Okay, so this is the importance of crystallization process. So let us see how it is done. But before that I want to tell you that there is a activity number 6.9 which explains how we can perform this crystallization process, but you don't have to do it at your home because this is the very risky process or activity that we have to do in every only laboratory. Okay, so you have to only read this activity 6.9, but similar activity I am going to show you which is related to the crystallization. Okay, so see this activity carefully. By this video I am going to show you. see, by evaporation process, evaporation we have to do with seawater. Suppose I think you went for the tour or trip at the coastal region or seashore. So, you saw that so many times we can see that salt is there, okay. Then salt is obtained by the evaporation of seawater. So, however, this salt is impure and has some crystals. So, whatever salt is there in seawater, it is impure, but by the crystallization process we can get this salt or we can pure this salt, okay. So, how we can pure it? By the crystallization process. So, here it is given, crystallization is the process of formation of large crystals in pure state from their solutions. So, that salt is mixed with seawater, that is the solution, and from this solution we can get pure salt, and this process is called as a crystallization. So, let me see how it can be done. Okay, students. So, this is what is the process of crystallization. So, hope you understood how we can do this activity. Okay. So, another activity is given in your textbook, but I shown you how we can separate salt by the seawater or any by adding salt in a water also we can separate salt crystals which are in the pure form only. Okay. So, that this is also called as a crystallization. So, this is our last point of this lesson. So, children, we completed lesson number 6, physical changes and chemical changes. So, let us take a recap. We discussed here what is mean by physical change and what is mean by chemical change. So, when substance is going to change by their size, shape or physical properties, it is called as a physical change, and when the substance is going to chemically change, that is called as a chemical change or chemical reaction also we can say. Okay. So, we discussed some examples, and now today we discussed about galvanization, rusting of iron, and also we discussed about crystallization, and I told you how we can prevent rusting of iron. So, hope you all understood all these concepts. Okay. So, we will stop here. In our next session we will start our new lesson. Okay. Till then, thank you. Take care.